The variable shutter which we are about to explain was designed to be used in a motion picture camera. We now have our first look at an ordinary shutter of a set degree angle only. The shutter performs two distinct functions. One is performed by the disc portion and the other by the gap aperture. Setting the camera in motion by using the hand crank to slow it down, we can see that the shutter revolves in a vertical plane. This strip of purposely marked film shows us that the shutter makes one complete turn for every jump of the film. Each jump represents one frame. The disc part of the shutter has the task of coming in front of the film while the change of frame is in progress. If no shield was provided during this frame change and we were to shoot pictures, the result would be streaky as this, instead of the following sharp shot. But let's get back to our camera. No doubt you have a good idea of the important part that the disc portion plays during the frame changes. So, let's proceed now to explain the function of the shutter aperture gap. Observe how stationary the film remains while being exposed to light between the frame changes. This is the shutter operation known as the shutter speed. With the shutter in which the disc has a prefixed degree, a change of shutter speed is not possible unless the velocity of the revolving shutter is increased or decreased. This increasing or decreasing can be accomplished only by changing the camera speeds. But in cinematography, it's not practical because it would alter the true motion of the pictures when projected. But should we at this time make an alteration of our own, and finally introduce the variable shutter, then things will begin to happen. The first noticeable change consists of a switch in disc degree angle, which shall be explained later, and also in introducing a bar which extends out of the camera. Moving this bar downward permits an extra disc, up to now well hidden, to come into view. Gradually, a full disc or blind is formed. Moving the bar upward returns the extra disc to its original position. The auxiliary disc movement depends entirely on how the bar is moved. With the camera in motion, both discs would revolve superimposed regardless of the direction. If the extra disc is preset at this position, it would still revolve and yet retain the same position in respect to the top disc. Moving the bar while the camera is in motion would still permit the extra disc to revolve, but the position in respect to the other one would vary according to the manipulation of the bar. This closing and opening of the shutter gap is in principle similar to the closing and opening of a lens. One exception to this is that even at maximum closure, a lens would still have an opening left. With the shutter capable of giving us a full blind at any time, a complete closure is assured, and this is an important factor in making complete fades and lap dissolves. At this time, we shall remove the shutter discs and show you the little differential which forms this variable shutter unit. The drive begins here, moves to gear number 2, to number 3, and to number 4. Looking at the bottom of the auxiliary disc now, we find that a gear has been fastened there. This is gear number 5. If we remove it from the disc and insert it in the proper place, we have now completed the differential block. In moving the bar, note how the top gear will change position in respect to the lower one. May we also call your attention to this tongue spring. This emits a warning sound which alerts you when your shutter is in closed position when moving either forward or backward. Besides being used to make fades, the shutter can be preset at different apertures. For convenient operation, notches for intermediate settings and a nameplate have been provided. Incidentally, do you remember the change of disc angle when the variable shutter was introduced? Here is the explanation. With two discs of 170 degrees, we would find it impossible to obtain a full blind. To overcome this problem, a disc of a larger degree is used, and now the lower disc can easily be hidden from view when not in use. This is a minor change because the shutter has to be set at 1/2 open before a lens compensation of a full stop is required. The new shutter speeds for the various camera speeds from 1/18th second to 1/560th of a second, as well as other things, are fully explained in an informative booklet free of charge on request from Pellegrini. With the camera all reassembled, we shall proceed immediately to demonstrate these variable shutter uses. The lap dissolve, a combination of a fade out and a fade in, is our starting point. Having made use of this striped cardboard, we have at hand these 5 strips of film of about 40 frames each. This is a fade out, from light to dark, of white lines more or less in a vertical direction. Next, a fade in of white lines in a horizontal direction. The 2 strips underneath have the same images as the 2 above, except that they are in negative film. The black is now transparent, and the white lines are now black. The last strip, also a negative, has both images of the fade out and the fade in. The lines begin here vertically. In the middle, both sets of lines are visible, and at the end only the horizontal lines remain. This is a lap dissolve. It was done as if the 2 films, one with a fade out and the other with a fade in, had been superimposed. Except for a noticeable darker density of the top one, the images are identical. On the real lap dissolve, only 1 strip of film was used. First, a fade out of the subject was accomplished. Then the card was set for the next scene. But before shooting, the film in the camera was backwound approximately the same amount of frames which the fade out took. As the fade in was then shot on the same film which the fade out was taken, the lap dissolve was accomplished. When properly used, lap dissolves do tie scenes together as in title work. They can very well be used to depict wishful thinking or flashback in a story. It's also good practice to use them to show simultaneous action. Lap dissolves from close-up to long shot add fluidity and drama to scenario pictures. They are effective to bridge distances, whether they are shot from a moving vehicle or as occasionally for static scenes employing lenses of different focal lengths. Perhaps best of all, they are used to depict lapse of time. Several months have passed between these 2 scenes. Our next subject calls for this unequally lighted scene. This is to see what can be done about exposures if the person standing at the right was to walk through and we were to follow her. Right exposure here, but now overexposed. Now we shall set the exposure for this point and follow toward the darker side. Of course, underexposed. We shall start again with an F4, but as we pan toward the lighter side and back to the shade, we shall lower the shutter control bar to increase the shutter speed, and raise the bar to decrease the shutter speed. Yes, darling, once more. Definitely, the changes in shutter speed have improved our scenes. Surely you haven't forgotten the notches on the bar guide and how we can obtain different shutter openings by locking the lever at these intermediate settings. These settings correspond more or less to the different shutter speeds with which most still cameras come equipped. These shutter speeds have various applications in still photography, and in connection with cinematography we shall discuss two of them. One advantage is that we could safely shoot outdoors with very fast black and white films such as Ansco SSS or Kodak Super XX, rated at 100 by Weston. Without a fast shutter speed, even when using the smallest lens aperture, the aid of a neutral density filter would become a must. That is, if we were to obtain a scene well exposed as this one. With no filter or a fast shutter, these black and white films would result overexposed. For our last subject, we shall demonstrate action shots at different camera speeds and at different shutter speeds. This young girl will now perform some rope jumping, and we shall shoot 4 scenes from the same angle. The first one at 1/53rd of a second, normal speed, and shutter fully open. The second one at 1/210th of a second, yet at normal speed, but the shutter set at 1/4 open. The third one at 1/140th of a second, slow motion, with the shutter fully open. The last one at 1/560th of a second, slow motion again, but the shutter set at 1/4 open. Through consecutive projection, actually we don't see anything unusual other than the different motion. But let's stop the projector and start from the beginning. By lining up the camera, we aim to duplicate the scenes off the screen by means of single frame operation. 1 frame and 1 camera click, 1 frame and 1 click, and so on. In using multiple scenes, note how the rope is almost lost on the first image. Viewed 1 frame at the time for stopped action as for making enlargements, the difference between the 2 frames is quite evident. The one at 1/210th of a second is even sharper than the first one at slow motion. The last one is where the action is completely stopped, and if we were to enlarge, we would certainly pick a frame from this one. So, that's the story of the variable shutter unit, a unit that takes 47 parts to make it tick, plus 1 for advertisement purposes.